Hello students, these are the topic tests by Bodhee Prep for Quant. These tests should be taken once you've completed the basic concepts of a topic to understand whether you're able to apply those concepts in a test manner. Once you take the test, there is a video with every test which gives you the solution of the test and also gives you a brief analysis of what would have been a good attempt and the kind of time that would have been put to attempt those questions. There are more than 200 such topic tests available on the Bodhee Prep Android app. So if you want to make use of these tests, all you have to do is download the app, the link for which is in the description of the video. So do that and make the best use of these tests. This video is on the topic functions, and this is the first test on functions on the app. Overall, I think the test was a moderate level of difficulty and 5 to 6 questions net correct would be a good attempt. 90 to 95 percentile plus will you will get if you get 5 to 6 questions net correct after reducing the negative marks. And the ideal time for this attempt would be about 25 odd minutes because there were some questions where calculation is involved that kind of increases my attempt time for this test. If we look at the questions, the first question says f is a function such that f of m into n is equal to f of m into f of n for positive integers m and n. If f1, f2, f3 are positive integers and f1 is less than f2, f24 is given as 54. What is f18? Now we know that f24 can be written as f of 12 into 2. This will be f of 12 into f of 2. Further, f of 12 can be written as f of 4 into 3. And f of 4 can be written as f of 2 into 2. So if we actually break this down, we replace f of 4 here and then replace f of 12 here, we can write f of 24 is equal to f of 2 into f of 2 into f of 2 into 2 into 2, which is 8 into 3. So this becomes f of 24. Similarly, for we have to find f of 18. For f of 18, we can write 18 is nothing but 3 square into 9. So this can be written as f of 3 into f of 3 into f of 2. So basically, to find the value, to find the value of f of 18, we need the values of f of 2 and f of 3. Now we break down 54 therefore, because there is no other step that we can do. If we break down 54, we will get 54 can be written as 27 into 2. That is 3 into 3 into 3 into 2. This is what 54 is equal to. Now, if we compare these two sides, we can see that there are 3 f2s, there are 3 3s. There is one f3, there is one 2. And therefore, we can say f of 2 is equal to 3, whereas f of 3 is equal to 2. That is one solution for this. And therefore, replacing the values here, we can get 3 into 3, sorry, f of 3 into f of 3. This will be 2 into 2, and f of 3 is 2. And hence, my answer becomes 12. Again, if you look at this question, I'd say this question is actually a moderate to difficult level of question because it is a little difficult to get the crack that all we have to do is break down 24, 54 and equate them. But apart from that, now the calculation is involved is not very high. So I'm saying moderate to difficult question, but the attempt time would be somewhere around 2 to 2.5 minutes. A function fx satisfies f of 1 is 3600, f of 1 plus f of 2 plus f of 3 up to f of n is n square fn for all positive integers n greater than 1. What is the value of f9? So here what we tend to do is we find out f of 1, 2, 3 and so on and look for a pattern. So f of 1 is given as 3600, that is there. For f of 2 we will write f of 1 plus f of 2 is equal to putting the value of n as 2 square into f of 2. This becomes 3600 is equal to 2 square minus 1. 3 times f of 2. So f of 2 will be nothing but 3600 upon 3. If you look at f of 3, we will write f of 1 plus f of 2 plus f of 3 is equal to 3 square into f of 3. 3 square into f of 3. F of 1 is 3600. F of 2 is 3600 by 3. This becomes 3 square 9 minus 1. 8 times of f of 3. This can further be written as 3600 into 1 plus 1 by 3, which becomes 3600 into 4 by 3 is equal to 8 into F3. 4 twos are 8, therefore F3 becomes 3600 upon 6. 2 threes are 6. I'll just look for one term to be sure in the end. F of 1 plus f of 2 plus f of 3. F of 1 plus f of 2 plus f of 3 plus f of 4 is equal to 4 square f of 4, which will be 3600 into f of 1 is 1, f of 2 is 1 by 3, f of 3 is 1 by 6, 16 minus 1, 15 f of 4. So this becomes 3600 into 6621 is equal to 15 f of 4, which means 3600 into 10, 6, 7, 8, 9, sorry, 9 by 6 is equal to 15 f of 4. 3 threes are, 3 twos are, 3 fives are. And therefore f of 4 comes out to 3600 upon 5 twos are 10. Now if we look at the individual values, this is nothing but 3600 upon 1. This is 3600 upon 1 plus 2. This is 3600 upon 1 plus 2 plus 3. Looking at the pattern of the denominators, 3600 upon 1 plus 2 plus 3 plus 4. Now these 1, 3, 6, 10 are numbers that should be obvious in the sense that you should be comfortable with this series. And therefore we say f of 9 is equal to 3600 upon 1 plus 2 plus 3 plus 4 up till 9. This is nothing but 3600 upon 45. 9 plus 1, 10, 8 plus 2, 10, 7 plus 3, 10, 6 plus 4, 10 plus 5. 3600 upon 45 will come out to 80. Hence my answer becomes 80. Again, this spot is a little important. The denominators, these numbers 1, 3, 6, 10, and how the series is progressing, that becomes the crack for this question. Overall, I'd say moderate to maybe difficult level of question and easily 2.5 to 3 minutes to get the question correct. The function fx is defined for all real values of x as 2fx plus f of minus x is equal to x square. What is the value of f5? So since there are two different functions, what we do is we first of all put x as 5. So we get twice of f5 plus f of 1 minus 5 is minus 4 is equal to 5 square. Now, since we want to get f5, we would try to create 5 from the other equation as well. So if I put 1 minus x as 5, we get x as minus 4. So putting x as minus 4, we will get 2 times f of minus 4 plus f of 5. Putting 1 minus x as 5, we get x as minus 4. So minus 4 square. This is equation 1. This is equation 2. We can, or writing these equations with their values, we get, from here we can write twice of f5 plus f of minus 4 is equal to 25. For the second one, we can write twice of f5 minus 4 plus f5 is equal to 16. We want to eliminate f4. This is equation 1, this is equation 2. Multiply equation 1 by 2 and then subtract equation 2 from there. So 4 times f5 plus 2 times f4 minus 2 times f4 gets cancelled. Minus f5 is equal to 25 into 2 minus 16, which means 3 times f5 is equal to 50 minus 16, which is 34, and therefore f5 comes out to 34 by 3, which is option C. Again, these questions have a straightforward process, and that can be repeated for almost 70 to 80% of these questions. So I'm saying moderate and about 2 to 2.5 minutes of attempt time. If square bracket x represents the greatest integer less than equal to x, then the value of. Now this basically returns the integer which is just less than the value. So GIF, greatest integer function 3.4, will give us the value as 3. Here we have cube root of 251, 252, 253 and so on. Now if we take the cubes, we realize that 4 cube is 256 and sorry, not 4 cube, 6 cube is 216. No, 6 cube is 216 and 7 cube is 343. And therefore cube root of 216 will give me 6. Cube root of any number after 216 will be 6 point something. And this will go until 342. Cube root of 342 will also be 6 point something. Cube root of 343 will become 7. So if you look at these numbers from 251 to 342, from 251 to 342, the number of numbers is 342 minus 251 plus 1, which will be 50 here. 92 numbers will be there from 251 to 342. So for the first 92 numbers, we'll have 6 point something. Suppose I'm writing 6 point x. X could take any value. Plus 6 point x plus 6 point x and so on. This will be there 92 times. Then we will have numbers from 343 to 350. These will be 8 numbers. So for 8 numbers, we'll have 7 plus 7 point something plus 7 point something and so on 8 times. So the net output from here, 92 and 100 values are there. So the net output from here will be, for the first 62 terms, we'll get 6 as the output. So 6 into 92. For the next 7 terms, we'll get, for the next 8 terms, we'll get 7 as the output from the GIF. So 7 into 8. 6 into 92 will be 540 and 12. 552 plus 56, which will come out to 608. Hence option D becomes the answer. I'll call this question a easy to moderate question because all we have to do is we have to look at the cube roots and then the pattern becomes pretty easy, and there is just one point where the value is changing. So even the final term that we are getting will not include too many calculations. So about 2 minutes to solve, easy to moderate question. 5 times f of x plus 4 times f of 4x plus 5 upon x minus 4 is equal to 9 times of 2x plus 1, where x is a real number and x is not equal to 4 because of this. What is the value of f7? Again, for questions like this, the first thing that you check is put x as 7 first of all. So 5 times of f7 plus 4 times of 4x plus 5. 4 into 7 plus 5 upon 7 minus 4. This will be 28 plus 5, 33 upon 3, which is f11. So 4 times of f11 will be equal to 9 times of 2 into 7 plus 1. This is 7 2s are 14 plus 1, 15. 15 into 9 will be 90 and 135. Next, we want to interchange the values. So what we do is we put x as 11. 5 times of f11 will be 4 into 11 plus 5 upon 11 minus 4. This will be 44 plus 5, 49 by 7, which comes out to 7. 4 times of f7 is equal to 9 times of 2 into 11 plus 1. So this is 22 plus 1, 23. 23 into 9 will be 180 plus 27, which is 207. Suppose this is equation 1, this is equation 2. Add equation 1 and equation 2 because the coefficients interchange. Therefore, 9 times of f7 plus 4 plus 5. 9 times of f11 is equal to 207 plus 135, which is 342. Dividing by 9, we get f7 plus f11 is 342. 479. 9 4 is 36. 9 3 is 27. 7 to 9 is 72. Then what we do is we subtract the second equation from the first one. So 5f7 minus 4f7 is f7. 4f11 minus 5f11 is minus f11. 135 minus 207 will be a negative value. 65 and 7, 72. This is equation 3 minus of 72. This is equation 3. This is equation 4. Add equation 3 and equation 4. So twice of F7 will come out to F11, F11 cancel, 38 minus 72, 38 minus 72, which will be 34, minus 34. And therefore F7 will be minus 34 by 2, which is minus 17, becomes the answer, option A. Again, in terms of level of difficulty, I'd say moderate to difficult if you do not know the process, otherwise moderate, and about 2 to 2.5 minutes to solve the question. The process is standard. All we have to do is follow the process. A function fx is defined for all natural numbers as f of x is equal to twice of f of x minus 1 plus 5. So every term is 5 added to twice the previous term. F of 1 is equal to 1. Now if you put x as 2, we'll get f of 2 is equal to 2 times f of 1 plus 5, which is f of 2, becomes 2 into 1 plus 5, which is 7. 7. F of 3 will be 2 times of f of 2 plus 5, which becomes 7 to the 14 plus 5, which is 19. Now, we have to find out F40 minus F39. If we look at F2 minus F1, we see that the number is 7 minus 1, which is equal to 6. If we look at F3 minus F2, this is nothing but 19 minus 7, which is equal to 12. We're looking for a pattern. Now, F2 minus F1 is nothing but 6 into 2 raised to power 0. This is nothing but 6 into 2 raised to power 1. So we can say that Fn minus Fn minus 1 is equal to 6 into 2 raised to power n minus 2, where n is 2, n minus 1, this is n minus 2. N is 3, n minus 1, n minus 2, and therefore F40 minus F39 will be equal to 6 into 2 raised to power n minus 2, which is 38. Hence, option D becomes the answer. Again, this is a standard process. Wherever you have a term like that, simply look at this, either interchange values, form an equation, or look at a pattern for the first 3-4 terms. Once you get the pattern from the options, that pattern can be replicated. I'd say moderate level of question, not more than 2 to 2.5 minutes to solve the question. For a real number x, fx is defined such that 1 by 1 plus f, if x is non-negative, that is 0 or positive. If x is 0 or positive, 1 plus x if x is negative. Also, iteratively, f of fn times x is equal to f of n minus 1 times x. N can be 2, 3, 4, and so on. What is the value of f2? Now, f2, if we find out, f2, since 2 is positive, will be 1 plus 1, 1 upon 1 plus 2, which is 1 by 3, which is a positive number. So, f2 times of 2 would be f of f2, which will be nothing but f of 1 by 3, because f2 is 1 by 3. Again, this is positive, so 1 plus 1 by 3 will give us 3 ones are 3 plus 1. 3 by 4, 4 by 3 reciprocal. F 3 times of 3 will be nothing but f of f2 times of f3 times of 2 will be f of f2 times of 2, which will be f of 3 by 4, which again, which is positive. So 1 upon 1 plus 3 by 4. This will be 4 ones are 4 plus 3, 7. So 4 by 7. So if we start from here, f2 was 1 by 3. F square of 2 was 3 by 4. So basically 1 plus 3 comes here. F 3 times of 2 is 4 by 7. So denominator goes at the top. 3 plus 4 comes here, and this pattern will repeat. So we have this, we have this, we have this. F 4 times of 2 will be nothing but 7 upon 4 plus 7, 11. And F 5 times of 2 will be nothing but 11 upon 7 plus 1, 18. 3, 3 cancel, 4, 4 cancel, 7, 7, 11, 11 cancel. And therefore the value remaining will be 1 by 18, option B. I think this was an easier question. The pattern is easy, and even if we're not able to spot the pattern, we just have to repeat this calculation 5 times. After this, we'd said the next term will be 1 upon 1 plus 4 by 7. And we'll get 7 by 11, and the next term will be 1 upon 1 plus 7 by 11, and we'll get the fifth term. So even if we have to do the entire calculation, the time might increase, but the level of difficulty, I think, remains easy. Consider a function f of x plus y is equal to f of x into f of y such that x and y are positive integers. f1 is 2. f1 is 2. Now we can say that f of 2, which is 1 plus 1, will be f1 into f1. So this will be 2 squared. If you look at f of 3 will be nothing but f of 2 into f1, because 3 is 2 plus 1. This will be 2 square into 2, which is 2 cube. And therefore, this process continues. f4 will be 3 plus 1. So 2 cube into 2, 2 raised to power 4. So we can say fn is nothing but 2 raised to power n. Now we have the equation as f of a plus 1 plus f of a plus 2 till f of a plus n is 16 raised to power 16 into 2 raised to power n minus 1. A is equal to. So f of a plus 1 will be nothing but 2 raised to power a plus 1 plus 2 raised to power a plus 2 at this until 2 raised to power a plus n, and this is 16 into 2 raised to power n minus 1. This is being added. So what we can do is we can take out 2 raised to power a common. We will be left with 2 here, 2 square, 2 cube, and so on till 2 raised to power n. This is 16 raised to power 2n minus 1. Now the property of powers of 2 is 1 plus 2 we know is 3, which is 2 raised to power square 2 minus 1. 1 plus 2 square is 4 plus 3 7 plus 1. 4 plus 2 6 plus 1 7, which is 2 cube minus 1 and so on. So 1 plus 2 plus 3 up to 2 raised to power n will be nothing but 2 raised to power n minus 1 minus 1. So here if we add and subtract 1, we get 2 raised to power a into 1 plus 2 raised to 2 square up to 2n minus 1 is equal to 16 into 2 raised to power n minus 1. This further becomes 2 raised to power a into the first n plus 1 terms will be 2 raised to power n plus 1, the next power of 2 minus 1, and then the minus 1 that we had. This is 16 raised to power 2n minus 1. This further becomes 2 raised to power a into 2 raised to power n plus 1 minus 2. 2 raised to power n plus 1 can be written as 2 raised to power n into 2. So we take the 2 common, this becomes 2 raised to power a into 2 is equal to 2 raised to power n minus 1, which is 16 into 2 raised to power n minus 1. 2 raised to power n minus 1 cancel, 2 16s are 8. 2 8s are 16. Therefore, 2 raised to power a is equal to 8, which is 2 cube, and therefore the value of a comes out to 3, which becomes my answer to this question. I'll call it a moderate to difficult level of question because, again, spotting the pattern is not difficult in this question, but beyond this point, uh, rearranging to get the left-hand side and the right-hand side form might be a bit of a challenge. So easily 2.5 to 3 minutes to solve this. And the question also moderate, if not difficult. If fx is equal to ax square plus bx plus c, where abc are positive integers, f0 is 2, f1 is 10, f2 is 28. If we put the values here, we can solve ABC probably. Find the value of x for which fx is minimum. All three are positive increasing values. Okay. So what we can do is if we write f of 0, this will be put x as 0. So a into 0 plus b into 0 plus c. This is given as 2. So from here we get c is equal to 2. If we put the value of f1, put x as 1. So a plus b, the value of c is 2. This is given as 10. This implies a plus b will be 8. And finally, f of 2, put x as 2. So 4a plus 2b plus c, which is 2, is equal to 28, which means 4a plus 2b is equal to 26 divided by 2. 2a plus b is equal to 13. This is equation 1. This is equation 2. We get 2 minus 1. 2a minus a is a. B minus b is b. 13 minus 8 is 5. So A comes out to 5, which means B will be nothing but 8 minus 5, which is 3. So the function fx becomes 5a squared plus 3a, sorry, 5x square plus 3x, 5x square plus 3x plus c. We have to find the value for x, which is the minimum. So either we can differentiate. So 10x plus 3 is equal to 0, x will be minus 3 by 10. Or I'll complete the square, x square plus 3 by 5x, which is not c but 2, I'm sorry, plus 2 by 5. So this becomes 5 into x square. We need to write this in the form of 2ab. So I multiply by 2 and then divide by 2. So this becomes 3 by 10x. Write the square of 3 by 10 and subtract the square of 3 by 10. This becomes 5 into, this is the perfect square. So x plus 3 by 10 square minus 9 by 100 plus 2 by 5. We do not have to find the minimum value. We just have to find the point where it is minimum. So this term will be minimum and this is 0, which means x plus 3 by 10 is 0, or x is equal to minus 3 by 10 or minus 0.3 becomes my answer. We could have differentiated this point to get a quicker answer as well, because we're just looking at the value of x. In any case, I'd say this is an easy question. 3 values, solving, and then finding the minimum. All of the two are standard processes. So in terms of level of difficulty, easy conceptually. Attempt time can go up to maybe 2.5 odd minutes. For a real number x, let fx is defined such that it is 1 upon 1 plus x if x is non-negative, that is 0 or positive, and 1 plus x if it is negative. And iteratively, if n times x is f of n minus 1 times x, where n is 2, 3, 4, and so on. Now the question is, r is an integer greater than equal to 2. What is the value of fr minus 1 times f of minus r, fr times f of minus fr times minus r, and r plus 1 times minus r? We know that r will be, r is positive because r is given as greater than equal to 2. So minus r will be negative. So we will end up using this. Suppose we take r as 2. So this putting r as 2 in the entire expression, we get r2 minus 1 is 1. F of minus 1 plus f2 times of f of minus 2 plus f2 times of minus 2 plus f3 times of minus 2. Now f of minus 2 will be 1 plus x, f of x, 1 minus 2, which will be minus 1. f2 times of minus 2 will be f of f minus 1, f of f minus 2, which is f of minus 2 is minus 1. So f of minus 1, which will come out to 1 minus 1, which will be 0. This becomes 0. And then if you look at f3 times of minus 2, this will be nothing but f of f2 times of minus 2. f2 times of minus 2 is 0, so f of 0. f of 0 will be 1 upon 1 plus 0, which will be 1. So if we add these three terms, the answer that we'll get is 0. And this will happen every single time. Even if you put r as 3, the third term will become 0, because if we start with, say, f of minus 3, f of minus 3 will be 1 minus 3, which is minus 2. F of 2 minus 3 will be f of minus 2, which will come out to minus 1. f3 times of 3 will come out to 1 minus 1, which is 0. And f4 times of 3 will then become 1. If you look at three terms, they will always be minus 1, 0, 1, which will add up to 0. The pattern is clear, but I think while solving such a question, it is always advisable that you take a simple value, put that value and solve for the expression. If you're not sure with one value, take two values. So taking r as 2 and 3 will give us the answer. So a moderate level of difficulty question. Attempt time might go up to 2.5 odd minutes. But in terms of level of difficulty, I would not say that it is difficult as such. So if we look at the overall test, Moderate level of difficulty, 5 to 6 questions, net correct required for a 95 plus percentile, and 25 odd minutes to get those questions. If I had to find my easiest questions among these 10, for me, they will be 2, 3, 4, 6, 7, 9. Which are these ones? I'm not counting this question because here it kind of stuck that 24 and 54 can be broken down, but might not be able to do it if the values were a little difficult. So not counting this question. This I would have done. The pattern is simple: 1, 3, 6, 10. This I would have done. The process is repeatable and it has been used in multiple questions. Again, this I would have done. Greatest integer function. Typically, the expression looks difficult, but the output is very simple. It is an integral. So tend to attempt those questions. Again, here because 4x plus 5 on x minus 4 is there, therefore not counting this as an attempt question, at least not the easiest 6. This I would have done. The pattern was pretty simple to spot, and then taking the difference, give the answer in terms of the options given. This also I would have done because there were only 5 calculations that had to be done in the worst case scenario. So might take some time, but will always give us the answer. I am not counting this because the rearrangement might be challenging. So not counting this as an attempt. Would have done this. The process is pretty simple. Solving for 3 variables and then finding the minimum of a quadratic. Again, I'm not counting this one as the easier attempt because if we deal with R rather than a value, then this might become a little challenging. Putting a value makes it simple, but I'm not counting this as an attempt. So for me, my 6 easy questions will be 2, 3, 4, 6, 7, and 9.